Hey everyone, welcome back to another lesson in Math 2. So far, we've talked about some basic things about a parabola, like the shifting of the parabola or the translating of a parabola and how to identify that, basically moving the vertex around. We've talked about whether a parabola opens up or opens down. And then we've also talked about the slope pattern of a normal parabola, of the parent function of parabolas, y equals x squared. Today, we're going to extend our understanding by taking these parabolas and not just shifting them around, but stretching them out or shrinking them down. You'll see what that looks like as we go along. So our goal today, our objective, is to be able to describe how a parabola is being transformed. And so basically, there's going to be three major things that you're going to say to describe a transformed parabola from the parent function. Number one is the parabola reflected. Number two is the parabola stretched or shrunk. And number three is the parabola translated. So you already know number one and number three. We're going to focus on number two today. But before we do that, let's talk about a quick review of vertex form. The overall vertex form is y equals a times x minus h squared plus k. And remember from the last unit, or the last lesson I should say, the hk is the vertex of the parabola. So we know that since this is x minus h, we actually change the sign of whatever we see here to identify the x value of our vertex. And since this says plus k, we're going to keep whatever sign there for our y value of the vertex. So our vertex, again, is h comma k. We'll see more examples of that in a little while. And then we also remember that the a value does something. If the a value is positive, then the parabola is going to open up, running out of room there, okay? And if the a value is negative, then the parabola is going to open down, okay? So it's going to look something like that. So that's generally how parabolas go. They either open up like a cup or down like a frown. So a being positive makes it up, a being negative makes it down. So those are the things that you know so far, okay? And then, and one more thing, you know that the normal slope pattern is 1, 4, 9. That means from the vertex, you go up 1 over 1, and then from the vertex, you go up 4 over 2, and then from the vertex, you go up 9 over 3. And then that continues on based on the perfect squared pattern. That is the normal slope pattern, the normal movement that we do. But we're going to talk about what happens when the a value is something other than 1 or negative 1 and how that affects the slope pattern today. Okay? So the a value changes the slope pattern. If a gets bigger, then these values are going to get bigger. If a gets smaller, then these values are going to get smaller. So let's go ahead and take a look at an example of what we're talking about here. Okay? In this problem, it says describe the transformation and graph the parabola for the following functions. Well, function in this case. Here we have y equals 2 times x minus 1 squared minus 3. So we want to describe the transformation, okay? Well, the first thing we're going to do is we're going to say, we're going to look for whether the parabola was reflected about the x-axis. In other words, this is the normal parabola, y equals x squared, okay? If it opens down, then it's reflected about the x-axis. Well, we can see in this case that the parabola is not reflected about the x-axis because the a value is not negative. Okay? The second thing we're going to do is we're going to focus on the actual numeric value of a. We notice that that is not 1. Remember, in our parent parabola, y equals x squared, the a value is 1 here. Okay? Well, our a value is not 1, it's 2. So what we say is the parent function, and that is y equals x squared, is vertically stretched by a factor of 2. the parent function is vertically stretched by a factor of 2 because that a value is 2. If it was 3, then it would be vertically stretched by a factor of 3. Okay? So it's vertically stretched by a factor of 2. And then we also notice that we moved our vertex. So let me go ahead and identify my vertex here. We know that the vertex, remember, is, we change the sign of this one, so the vertex is 1, comma, and we keep that sign -3. Okay, so that's the vertex of this parabola. The vertex of this guy, our parent one, is 0, 0, right? So we have to describe that transformation or that translation. We would say shifted or translated 1 unit right, because we went from 0, we went to 1, so we went 1 unit right, and 3 units down. 3 units down, because we went from 0 to -3, so we went down 3 units there, okay? So that's describing the transformation. The vertex is 1, -3, and therefore we could say that the parabola was vertically stretched by a factor of 2, and it was translated 1 unit right and 3 units down. Okay, so that's probably a little bit clearer in this here. But now we want to go ahead and graph this parabola. Now normally we would be able to graph it pretty easily. So let's go ahead and do that. I'll go ahead and do it off to the side here. Draw my XY plane. All right, so there's my parabola. We start at the vertex, and since the vertex was 1, -3, we're going to go to the right 1 and down 3. That's where we start. Okay. And then from there, we have to identify our slope pattern. Now, we know that our normal slope pattern is 1, 4, 9. But because our A value is not 1, that's the slope pattern for this guy, our A value is not 1, that means our slope pattern changes. So let me rewrite it this way. Remember, 1 doesn't actually mean 1, it means 1 over 1. And then the 4 doesn't actually mean 4, it means 4 over 2. And then the 9 means 9 over 3, because we're taking the denominator and we're squaring it to get to the numerator. Taking the denominator and squaring it to get to the numerator. Same thing on the bottom one here. So 3 squared is 9, 2 squared is 4, 1 squared is 1. We can continue on in that pattern if we'd like. But this is the normal slope pattern. What we need to do is we need to multiply it by 2. We multiply it by the A value. So when I multiply these by 2, remember when we multiply fractions, it's actually 2 over 1. So this new slope pattern is going to be 2 over 1. Notice the denominator did not change, just the numerator did. So the top becomes 2, the bottom remains 1. On the next one, it would be 8 over 2. So we multiply the top by 2, keep the bottom. And then the next one would be 18 over 3. And so this is our new slope pattern because the A value is 2. And so we go over to our vertex, and we're going to go up 2 and right 1 for our next point. And then the third point there, we're going to start at the vertex, and we're going to go up 8 over 2. So up 1, 2, 3, 4, 5, 6, 7, 8, and over 2. And we get our third point there. And then if we wanted our next one, we'd go up 18 over 3, but I'm running out of room there. Now remember, we want to reflect those points across the axis of symmetry. So I'm going to draw my axis of symmetry here. And we're going to say, okay, this point is 1 unit away from the axis of symmetry. So I'm going to fill in another point on the other side that's 1 unit away. Same thing with this point. This point's 2 units away. So the other point will be 2 units away on the other side. And so there we have graphed our parabola. And notice that this parabola looks a little bit skinnier, if you would, than our normal parabola. Because instead of going up 1 over 1 and then up 4 over 2, we are going up a different amount. We're going up higher as we go over. And so it makes it look a little bit skinnier or narrower. Okay? So that is our example of how to graph a parabola. Again, you take the slope pattern and multiply it by 2. And so we end up with 2 over 1, 8 over 2, and 18 over 3. All right, here's some practice for you. So remember, you should be doing the practice problems on the left-hand side or the left page of your notebook. Okay, you want to describe the transformation and graph the parabola for each of these functions. So go ahead and pause the video and then come back and compare how you did to what I did. All right, for number one, the first thing we're going to look for is, do we have a reflection? No, we do not have a reflection because the A value is not negative, okay? Next thing we look for is any kind of vertical stretch or shrink. We would say that our parabola is being vertically stretched by a factor of 3. The parabola is vertically stretched by a factor of 3 because the A value is 3. And then we notice that the vertex is negative 2, 1. So we translated the vertex 2 units to the left and 1 unit up, okay? So the verbal description is going to be very important in terms of writing your answers out. So that's what happened to the parabola. Now we want to go ahead and graph the parabola. So let me create my my XY plane again on my graph paper. I guess I should have had this done already. That would have been a prudent teacher, wouldn't it? All right. So we're going to look at our XY plane here. We have a vertex of negative 2, 1. So we're going to go back 2 and up 1. So there's our vertex. And then we need to look at our slope pattern now. Since our slope, our A value is 3, our slope pattern normally is 1, 4, 9. So we're going to take those values and multiply them by 3. So instead of 1 over 1 and 4 over 2 and 9 over 3, we're going to multiply all those by 3 here. And so we end up with 3 over 1, 12 over 2, and 27 over 3. So those are our movements. From the vertex, we're going to go up 3 and over 1. From our vertex, we're going to go up 12. Now I'm going to run out of room here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, way up here, 12 over 2. So something like that. That's a little bit off probably, but that's okay. And then we're going to reflect that, because I can't go any further, about our axis of symmetry. So that's 1 away. So this one will be 1 away. And then that one's 2 away. So that'll be 2 away. So we kind of get our idea for our parabola here. Okay. This one is exceptionally skinny, right? It's very narrow because the A value was bigger than even our last one. So you can see that if X is, or the A value is 1, we get a standard parabola. If the A value is 2, it gets skinnier, narrow. If the A value is 3, it's even narrower. So as the A value gets bigger, our parabola becomes narrower and narrower and narrower, okay? So that is your practice problem. Let's go ahead and take a look at another example here. We'll add a little bit more to this now. It says, describe the transformation and graph the parabola for the following functions. Again, same type of thing. First thing we want to do is identify our vertex, because that's the most important point out of the whole thing. Remember, to identify our vertex, we change the sign of H and keep the sign of K. So the vertex is going to be negative 4 and positive 9. Okay. Then the next thing we look for is our A value. What's happening on our A value? Number one, what's the sign of the A value? Well, in this case, the sign of the A value is negative, which means that this parabola is going to open down. And so the way we verbally express that is we say that the parabola is being reflected about the x-axis. It's reflected, it's a reflection about the x-axis, okay? That is because the A value is negative. The next thing we look at is that since the A value is a 1/2, that is going to change the thickness or the narrowness, if you would, of the parabola. But instead of stretching it out, we're actually compressing it because the A value is less than 1. So we would say that the parabola is being vertically shrunk by a factor of 1/2. It's being shrunk by a factor of 1/2. Whereas if A is greater than 1, it's vertically stretched. So stretching, shrinking, stretching, shrinking. And you'll see that in the parabola, okay? When we go to graph it. It's vertically shrunk by a factor of 1/2. And we'd also say it's translated 4 units to the left and 9 units up. Okay, so there is our description of our parabola. So now let's go through and actually graph this guy and see what it looks like in comparison to a normal parabola. Let's see, we've got a pretty high y-intercept there. Just make sure I can hit. Now, when we are vertically shrinking something, we might be able to get more points in our graph, and you'll see what I mean in a second. So again, remember our slope patterns are normally 1 over 1, 4 over 2, 9 over 3. We're going to multiply all those now by negative 1/2. Negative 1/2. Negative 1/2. What's another way of saying 1/2? Well, if you convert 1/2 to decimals, that's 0.5. Okay? So when I multiply this by 1/2, this is going to look kind of weird, but I'm going to really be multiplying it by 0.5. So the top becomes negative 0.5, and again, the denominator stays the same, so it would be over 1. Here, we're going to get negative 2 over 1, because half of 4 is 2. And then we just keep the, over 2 there. Keep the denominator the same. Just multiply the top, the numerator, by 1/2. Well, what is half of 9? Half of 9 is 4.5, 4.5, and then over 3. Okay? So we can see our new slope pattern based on those values. That's a little confusing. I get it, first time you see that. But the bottom line is you're taking your your numerator and finding half of it. Half of 1 is 0.5. Half of 4 is 2. Half of 9 is 4.5. Where the negatives come from? Because the a value was negative. Okay? So we go over to the graph now. The vertex was negative 4, 9. So we go back 4 and up 9. 5, 6, 7, 8, 9. So we've got this point right here is my vertex. And then from here, because the parabola opens down, it's reflected, we are going to go down 1/2, not down even 1, just down 1/2 and over 1. So you can see that my grid, my point is right in the middle of those two, okay? Then from there, we're going to go down, not from there, from the vertex, we're going to go down 2 and over 2. So down 1, 2, and over 2. So there's the point there. And then from the vertex, we're going to go down 4.5 and over 3. So from the vertex down 1, 2, 3, 4.5 over 3. And actually, we have a lot of room left on our graph. So let's keep going with this slope pattern. Remember 9 over 3, the next one would be 16 over 4. So when I multiply that by negative 1/2, well, half of 16 is 8, so we get negative 8, and then the denominator stays the same. So negative 8 over 4, so from the vertex, we're going to go down 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. We have that point. And I still have more room, so I'll keep going. The next slope pattern will be 25 over 5. We'll multiply that by negative 1/2. Well, half of 25 is 12.5. So we say negative 12.5 over 5. So we'll go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5, and then over 5. And I think I'll stop there as far as points. But you can see we can get a lot more points on our graph when the a value is less than 1. Then we're going to reflect those values onto the other side. So we have a point here. 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 And we have a point here. And so we get a pretty good idea of what this parabola looks like. Remember when you're sketching, you're doing little tiny lines and then picking up your pen or your pencil as you go along, picking it up and setting it back down. That's just a better way to get a more accurate looking curve. Okay? So there is your parabola. So we have described it. Remember, we're looking for 3 things in our description: whether it was reflected, whether it was vertically stretched or shrunk, and then whether it's translated, okay, or shifted, okay? So again, the slope pattern is 149. We're going to multiply that by the magic negative 1/2 and get those values. Get these values for our numerators, our top numbers, and then the denominators remain the same. All right, here is your practice problem for this. Let's see what you can do with this. This is pretty intense. There's a lot of parts to this because it's wrapping everything together from what we've done in parabolas all together, okay? So go ahead and push pause and answer these questions. And once you're done, come back and compare what you did to what I did to make sure you're on the right track. All right. For number 2, it says y equals negative x, negative parentheses, x minus 3 squared plus 5. So do we have, number 1, a reflection? Yes, we do, because the a value is negative. So we would say that the parabola is reflected about the x-axis, okay? Then we look for a vertical stretch or shrink. Since the a value is a 1 or a negative 1, there is no vertical stretch or shrink, so we don't have to worry about including that. It's going to follow the normal slope pattern. And then how is this translated? Well, the vertex is positive 3, negative 5. So that means it was translated 3 units to the right and 5 units up. Okay? So there we have the description. Now we're going to go ahead and graph our parabola. This one should be pretty straightforward because the a value is a normal 1, so we don't have anything weird going on there. And let's see here. So we are going to translate this thing 3 units right and 5 units up. So 1, 2, 3, 1, 2, 3, 4, 5. There's our vertex right there. We're going to follow the normal slope pattern because the a value was 1 or negative 1. It's 1 over 1, 4 over 2, 9 over 3. Now, if you want, you can think about multiplying by negative 1 on each of these because the a value is actually negative 1. But what do we get? We get negative 1 over 1, negative 4 over 2, negative 9 over 3, and that's just telling us that we're going down instead of up. So we're going to go down 1, right 1 from the vertex, and then from the vertex down 4 and right 2, and then from the vertex down 9, 2, 4, 5, 6, 7, 8, 9, and over 3. And then we'll reflect that on the other side, and we end up with our parabola. Okay, so that is part B there. That's our graph for our parabola, part B. Okay, and then part C, it says, what is the domain and the range? Well, the domain of any parabola, if there's no restrictions, the domain is going to be negative infinity, less than x, less than infinity, because this keeps going on to the left and to the right forever. For the range, well, what's the lowest point? The lowest point is how far this parabola goes down. It goes down forever, so we'd say negative infinity, less than y, and then how far up does it go? It goes up to this point, the vertex, and that point is 5 high, so we'd say less than or equal to 5. So that is C. For D, it says, over what interval is the graph increasing and decreasing? So where is this increasing? We can see that it's increasing in this region. Let me go ahead and highlight that for you. We can see that it's increasing to the left of our axis of symmetry. So all over here, we're increasing. So we start increasing at negative infinity, and we stop increasing at 3. So that's our interval of increase. And then our interval of decrease is going to be where it's going downhill. So that's everything on this side. Okay. And so we can see that that picks up at 3, less than or equal to x, and then it ends at positive infinity. Some students get confused on whether this is a positive or a negative infinity. It is going down to negative infinity. The y value is negative infinity, but it's moving to the right. As it goes down, it's moving to the right. And so that's positive infinity in the x direction. And because we answer the increasing and decreasing intervals in terms of x, we are going to the right, positive infinity. All right, for E, it says, what are the x and y intercepts? Well, the x-intercept's a little hard to see here because it doesn't actually cross at a nice, clean numeric value, right? We don't know that exactly. My graph's a little off here, but we can give a good estimate. We could say that the first x-intercept is going to be somewhere between 0 and 1. Oops, going to be somewhere between 0 and 1 because this point was 1, And if we have to move over just slightly at all, we'll say the x-intercept is like, I don't know, how about 0.9 comma 0? That's a pretty good estimate, okay, 0.9 comma 0. And then over here on the other x-intercept, that is just to the right of this point, or just to the right of 1, 2, 3, 4, 5. So we would say maybe 5.1 comma 0. Now, normally when I ask these questions, I'll either give you a method to solve it so you get an exact value, or it will line directly on a nice clean whole number. But in this case, it didn't, so that's okay. And then the y-intercept is going to be where it crosses the y-axis. We can see that it actually does hit the y-axis at a good clean point. That point is going to be 1, 2, 3, 4. So it'll be 0, comma, negative 4 for our y-intercept. Okay. And then let's see, F says, what is the axis of symmetry? Well, I kind of already drew it here. A lot of students are going to say the axis of symmetry is 3. Well, the numeric value is 3, but how do we express it? We express it as an equation. We write it as x equals 3. So please be careful with that. Axis of symmetry has to be written as x equals 3. And then the last part, G, it says, what is the average rate or the average slope? Same thing, average slope for the interval 2 to 6. So we have to go to our graph and we have to recognize the two values here. Well, at x equals 2, we have this point, okay? That coordinate is 2, comma 4, okay? And then for x equals 6, we got 1, 2, 3, 4, 5, 6. That's this point here. And that coordinate is going to be 6, comma, negative 4. Okay? So we have these 2 points and we're trying to find the slope between them. So all we have to do is count the slope. So we would count 1, 2, 3, 4, 5, 6, 7, 8. So our slope is going to be down 8. And then we went to the right 1, 2, 3, and 4. So that would be a positive 4. And so we can simplify that to be negative 2. So our average slope is negative 2 there. If you want the analytical way, we would take the two coordinates. Notice the x value is 2 and the x value is 6. There's our x for 2. There's our x for 6. And then we found the y values there. We find the slope. We use the slope formula. So it would be y2, which is negative 4, minus y1, which is 4, all over x2, which is 6, minus x1, which is 2. And then we simplify that. Negative 4 minus 4 is negative 8. And then 6 minus 2 is 4. And you can see that that also simplifies to negative 2. All right, that wraps up our lesson for today. Really, the main focus was figuring out what happens when the a value is something other than 1 or negative 1. And we discovered that that changes our slope pattern. And so that is either going to stretch the parabola out or shrink it down. So it's either going to be narrower or wider. And we talked about verbally expressing that. And then all these problems are just kind of a review of stuff we've done in the past. If you have any questions, please comment below or shoot me an email or come into tutoring and I'll help you out. But otherwise, have a great night.